So my name is Nikolaj Purup. I'm a data science developer at Ørsted, Danish energy company. So I've been working the last 10 years with data and analytics for different companies. Starting out with IBM and working for a smaller Danish shipping company called Lauritsen. Working for AP Møller Mærsk, a larger shipping company, and now working for Ørsted. So part of my role at Maersk was to travel out to ships and install IoT gateways. So some of these ships have never been streaming data before. And the first time I remember I installed one of these gateways and saw data flowing to the cloud, I was really hooked on IoT. I think it has such a huge potential. But when we connected that gateway, I also realized how much trouble you have to figure out before you can really create value. So in this presentation, I'll try to describe how to overcome some of the lessons learned. So first of all, a few words about Ørsted. So in 2017, we had a revenue of 60 billion with 6,000 employees. We do this with 4 business units. So offshore wind, onshore wind, bioenergy, and customer solutions. So offshore wind is by far our biggest business unit, with parks around the globe. Onshore wind is a smaller business unit, mainly with parks in the US. Bioenergy is going through a huge transformation these years, transforming from coal and into biofuels instead. So that's the power plants. And then finally, customer solutions, which are delivering smart ways to get the energy to the market. So this is kind of a bragging slide, but shows Ørsted's position within offshore wind. So as you can see, we are by far the biggest operator, both in terms of installed and planned capacity. But I think from a technical perspective, I don't care about the money so much, but I see a lot of data here. So I think that's awesome. So just to show where we do business, so mainly in Northwestern Europe, but also is going through a huge transformation these years and opening parks in Taiwan and bidding and constructing parks in the US as well. Yeah, so this is the last company presentation slide, and I think it's actually quite interesting because it really shows the rapid development that offshore wind has gone through for the last 25 years. So what you see here is it shows clearly how the development has been, but you also see how we have been developing on the physical dimensions, and I think we are kind of reaching a practical limit on how big these turbines can be, and I think IoT can play a huge role here in making smarter and more efficient operations with the same size assets. So I tried to think a bit about what's actually the end vision of all this IoT, because finally we have to create some value and not just make cool solutions, right? So I wrote this: connected machines that observe, decide, coordinate, and act independently to enable smarter operations. So I think that's what we should have in mind is kind of the end goal of all this. So these years we are seeing an unprecedented digitization of the physical world. So we are installing billions of devices, and we're able to stream data to the cloud and do advanced analytics and send recommendations back to the machines to optimize. That's at least what the technology is there to do. But what I've seen is that, especially for heavy asset operators, the implementation is slower than it is in other industries. So in this presentation, I'll look into why implementation is slow, especially in this industry. So just 1 second to think about what's the drivers of this digitization, because these asset operators, they're really under fierce cost pressure. So in Ørsted, we are now bidding for wind parks with 0 subsidies. So we're getting basically no money from the state for the energy produced, but operating fully on market terms. Another example is the shipping industry. They're operating with margins of just a couple of %. So if you, as a data scientist, can go in and find just a little bit on the operational side, then that really makes a difference between winners and losers in these industries. So and not only will IoT enable smarter operations, it will also make it possible to have new business models, as we have heard a bit about in the other talks. So talking about service-driven business models, so that might be the example that you might have heard about of General Electric selling propulsion power as a service instead of selling actual jet engines. And I heard a Danish example as well the other day, Grundfos, talking about selling pumped water instead of physical pumps. So again, the foundations to do stuff like this seems to be there. We have the cloud services, we have our knowledge of data science, but adaptation seems to be slow. And having worked with this for a couple of years, I think there's good reasons for this. So I tried to group it in 5 different topics. So first of all, starting on the upper right corner, infrastructure is a huge challenge here. So many of these assets are extremely expensive, and they're meant to be operating for many years. That also means that some of the assets that we're connecting to today, they were built maybe in the 90s or the 80s, and definitely not built to be connected to or optimized. So the next challenge is security. So IoT really represents a really close link between the virtual and the physical world, and that's a major headache for any operator of heavy assets. So I'll talk more about that later. But the next one I mentioned here is culture. So I think that's often overlooked, but I've seen that in various companies as well, that the people working on these projects, they're coming with really different backgrounds. So you have to facilitate the meeting of those cultures somehow. That leads me to the next one, which is setting the right team. So that's just super important, getting the right people on the team that are able to handle kind of full stack IoT pipelines end to end. And finally, data quality. It's the foundation for any data science. So I'll talk a bit about that later as well. First of all, the culture side. I think, as mentioned, that's really an overlooked problem, but I've seen it very often. So you have this in these projects a very physical side and a very digital side, and you see the same thing in the organizations as well. So on one side you will have the mechanical team, so that's or the physical team. That might be mechanical engineers or people with a IT security background, and they're kind of coming from a world where failures can mean billions or millions of dollars lost, or even have deadly outcomes. And then on the other part you have the digital part of the organization. So they are coming with this fail fast mentality and continuous releases, and you can hear that can be kind of a difficult match. So I think putting these people together and facilitating a environment where they can really create within fixed boundaries is super important to unlock the huge values of IoT. And that links to the next slide on a team that could be set up for doing kind of full stack IoT. So I put some thought into how which personas need to be on a team like this. So in my experience, it's super important to be able to take these projects all the way from a kind of an ideation phase and all the way to implementation. So on the ideation part of it, you will need to have someone with domain expertise. We also heard that in the other session, and I've learned the same thing, that having subject matter experts is just invaluable in projects like this. So I worked previously with a chief engineer who learned to write Python during the course of half a year, and I mean the ideas he came up with, they were much more advanced than or valuable than any of us data scientists could come up with, because he actually knows how things are like in the real world. Then it's important to have someone on the team who has the business insight, so someone who's able to prioritize the ideas, because I also have often seen this, that it's not the ideas that are lacking in projects like this. So usually you will have a really long list, and you need someone there to say what should be prioritized and what brings more business value. And then of course you need a data scientist to make sense of all the data being generated, and it can really be huge amounts of data for some of these systems. So that's the ideation part of it. Then we need someone to implement all these ideas as well. And having these groups to work closely together is really valuable in my experience. So on the implementation side, you need someone who's a software developer. And I've seen really often that software developers and data scientists are getting mixed together, and that's really something to avoid. Data scientists, they know how to do POCs and one-offs, whereas software development is really a craft where you need to know how to move things from a test environment to a production environment and make write testable and reusable code. And that's not necessarily something a data scientist know how to do. Then you need a data engineer on the team. That's also often misunderstood as a data scientist. So, but data engineers know how to move things through the different administrative zones that you often have in these IoT setups. And finally, you need someone from IT operations. So this system, whenever it's built and done and business starts using it, someone needs to know how to keep it alive in a stable manner. So, switching topic a little bit to security. That's just a major headache for anyone dealing with IoT, and especially within heavy assets. So, these heavy assets, they really they have a big impact on society as well. So, for many of these companies, it's simply not acceptable if any hackers get into these systems. So take something as Ørsted. On some days we produce 100% of the Danish electricity using the wind parks in the North Sea. Imagine if that was compromised. Or imagine a gas tanker that I was working with a couple of years back. If hackers take control of a gas tanker close to a huge coastal city, that would be catastrophic, right? So, but then on the other hand, we also need to move on some of these technologies. So we need to find ways to build secure IoT networks. And the challenge is really here that we span these different administrative networks. So usually we want to keep the IoT network completely separated from the OT network, and that's a good plan for starting up and doing POCs to install your sensors and not interfere with the OT zones at all. But at some point we need to mix the two together, and that requires a completely different setup. So I guess the advice here is to really scale the security with the complexity of your solution, and for as long as possible, keep a separate track for your IoT network. And then think security from the very beginning, because if it's something that comes as an afterthought, that might be really tricky. So data quality. That's probably also a often overlooked topic, and as the old saying says, garbage in, garbage out, and it's especially for operators of heavy assets, data quality is super tricky, because often you will have your sensors placed in environments that are either hazardous or very distant away, or scattered around the globe. So if a sensor is failing, you can't just take your car and drive out and fix it. So you need to build an organization that's able to handle this. So I tried to kind of list these 6 principles. I guess it's also lessons learned on how to improve data quality from the very beginning. So number 1 is to have some person responsible for the quality of each data set. So when a sensor is failing or it shows a strange value, everyone needs to know who's responsible for rectifying that. And that links to number 2. So if you, from the very beginning of the project, make sure to visualize the data and make it visual in the organization, and also the quality of the data, and someone is responsible for it, that helps a great deal to have things fixed. Then number 3 is to make a standardized sensor data format in your organization. So often dealing with all these legacy operational systems, operators that own a large fleet will have a multitude of different systems that need to be connected to. And oftentimes that each of these systems will be sending data in different formats, and that can really be a mess at some point. So if somehow you can enforce a standard sensor data format on your vendors, that's something that can really help your data quality later on. And then the 4th one it's a bit funny, but it's you only use UTC 0 as a timestamp, especially if you have assets that are moving around the globe, and you don't know what time zone the data has been recorded in. Then that really makes your data quickly useless, at least for some applications. Then number 5 is to keep a centralized master data repository of calibration factors and naming standards, unit conversions, etc. So often this information will be, at least in the beginning of data science and IoT project, will be scattered around the organization. And that's a huge risk, that where you end up with these spaghetti data sets that the data scientists, when they're actually supposed to do the data science, they don't know if the data sets have been calibrated or if the sensor actually means what it's supposed to mean. So you need this centralized system to keep track of what is actually the truth at any point in time. So it was also mentioned in the previous session, right, that a lot of this data is actually changing. So you're changing sensors and you're changing data loggers out there all the time. So those that are doing that needs to keep that updated at any given point in time. And then the final advice is to keep all these mappings and calibrations as possible, as close as possible to the source. So again, to avoid that there's any doubt within the organization if data sets have actually been calibrated or not, and to kind of keep this one truth. Yeah, and then finally a few words on infrastructure. So that's a huge challenge with all these legacy operational systems that you need to connect to. Especially if you own a very varied fleet of machines that run different systems from very different points in time. So I guess the bad news here is that you really have to start working with gateways that are able to connect in a secure way to each of these operational systems, and do all the calibrations and naming mappings as close as possible to the source. Then my second bullet here is to build a scalable platform. So build on cloud, because at least in my experience, that makes it really easy to take things from kind of a small POC to something that's scaled to the entire fleet. It also, you get a lot of things for free here, right? On security and especially on the IoT side. And then finally, try to build a modular system. So don't tie yourself to one vendor. Again, talking into what has been mentioned previously in the other sessions. So don't do these black box solutions with one vendor going with the entire solution. That these technologies, they move so fast these years that no doubt in a year or half a year you'll find some new technology you want to implement somewhere in your pipeline. And if you don't have a modular system, then you cannot do this. And use open source if possible. There's really a lot of development going on in this area within IoT these years. Yeah, so the main conclusions. First one is maybe easier said than done, but set the right team, combine a team with backgrounds from the physical and the digital side, and enable them to kind of do full stack data science from ideation and until delivering the final insight to business. Then build a scalable architecture, and just as important, make it modular, so you're able to adapt to new technologies coming to the market. And finally, get your data under control from start. So in a lot of these projects, you will see that you start collecting data and they end up in some shared drive or on some blob storage. And when you need to do your analytics, it's basically impossible because the quality is not up to standard. So get it. Start your project looking into data quality. Then you have a lot more valuable data to analyze in the end. So that's it. Any questions?